Welcome and good morning to Utkarsh Minds Python for Data Science. Today we will see how we can write the program for the binary versus ordinal variable hypothesis testing. First, I will open my Colab notebook. I will click on new notebook. Once the notebook is open, I can give the name binary, ordinal and click on connect. Further, I will need the data set, so I will upload the data set here. The name of the data set is student statistics. Next, once I get my data set uploaded, I will start writing the program for my binary versus ordinal hypothesis testing. In that, step 1 is to import pandas, import numpy and import matplotlib. Once all the files are imported, I can read my data. So data is equal to pandas dot read underscore cv. Here I will read student statistics dot csv. Separator is semicolon. We can also check the first few rows of the data set. For this I will also need one more package. So I will run this and see that yes, my data is correct. Then I will install the other package. So it is pip install this package has to be loaded from GitHub. So it has a big name. Error, could not install the package. So if you are also getting the same error, then there is a correction here. It should be slash. Okay, make sure that the path is correct, written as it is, like I have written. Otherwise you will get error. Once you are seeing a tick sign, we will import the package by writing sti as ps. Okay, so package is imported. As I said, the first step is to create a cross tab between the binary variable, which is gender, with the ordinal variable, which is mix nr act. So this cross tab will give us the distribution of data. So we have male and female, and here we have the ordinal variables, how they are distributed across this binary variable. Next, we have to convert the ordinal variable into number form. So each level of the ordinal variable I can extract by data mix nr act dot value count dot index. I think it is value counts. So here are the different levels. Now each level I must assign a number. So far too little is level 0. After that, too little is level 1. Enough is level 2. Too much is level 3, and far too much is level 4. Once this scheme is ready, we will call the function ps dot vi underscore bar stacked multiple. In this function we will pass the data binary levels, which is gender, and we will pass the ordinal data, which is, and the coding scheme. This should give us the stacked bar chart. So you can see that it has given us the stacked bar chart. Only we have to make sure that the coding scheme is in order. So I will replace this here 0 followed by we will write 1, then 2, then 3 and 4. Okay, so it has given us in 0, 1, 2, 3 and 4 in this order for each of the binary levels. Once this is done, we can apply the hypothesis test. For hypothesis test, we will create a variable myOrdinal, and from data we will have to extract the ordinal column, which is mix nr act, and replace the string with numbers. So we use the replace operation. Now that we have got ordinal data, we will get the two binary levels. So I will call them binary level 1 and binary level 2. From data I will extract gender, where it is male, and in the second we will write where it is female. This will give us male and female. Next, the ordinal scores for level 1 and ordinal scores for level 2. So we will extract all the ordinal data for each binary level. So for that, from myOrdinal, my binary 1, we will drop the missing values, and same we will do except for binary 2. So we have got ordinal 1 and ordinal 2. Once this is done, we will import from scipy.stats the function Mann-Whitney U. So Mann-Whitney U test. Here I will pass my ordinal 1 and my ordinal 2. So we are passing the ordinal levels for each binary data. Alternative has to be two-sided. And we also have one more argument here that we have to specify. That argument we will write as use continuity. So these are the 4 arguments that we have to pass, and when I run the function it gives us the statistic and p-value. So we are interested in getting the p-value, which is 0.0044. Since this p-value is less than what we have got as the threshold 0.05, so if p-value is less than 0.05, then I will print that my null hypothesis is rejected. The null hypothesis was that there is no association between gender and the activities performed. So the activities performed and gender have no association. Else we will say that null hypothesis cannot be rejected because our p-value is greater than 0.5. Since here we are getting p-value as less than 0.05, null hypothesis is rejected, and since alternate hypothesis is there is an association, so the alternate hypothesis that there is an association is probably true. Now we want to find out the degree of association, so that we will calculate using the Rosenthal correlation coefficient. Okay, so that is my effect size Rosenthal coefficient, correlation coefficient. We want to find out the degree of association, so that we will calculate using the Rosenthal correlation coefficient. Okay, so that is my effect size Rosenthal coefficient, correlation coefficient. To calculate that, we have a very simple formula from scipy dot stats import norm, calculate the z value, norm dot ppf. This will take the previous p value which is calculated from previous p value. Then I need the total sample size. So total sample size will come from my ordinal 1 and 2. So length of my ordinal 1 plus length of my ordinal 2. And then finally I will calculate my Rosenthal correlation coefficient as z divided by the square root of n. Further, the interpretation is that if the Rosenthal correlation coefficient is less than 0.2, then we will print that it is very low. The association strength is very low. If it is less than 0.4, we will print it is low. If it is 0.6, then it is moderate. Then if it is 0.8, then it is strong, and finally it is very strong. when I execute this, it should give me that it is a moderate strength of association. So that's it. We have seen in this how to calculate the cross tab, how to calculate the stacked bar chart, and finally how to calculate the Mann-Whitney test and the effect size. So at the end comes writing the report. We will say the Mann-Whitney U test has found that there is an influence or association between gender and activities. Here I will write p value is less than 0.5, and further the Rosenthal correlation coefficient suggests that the strength of association is moderate. So here I will have to give the value which I have got of my correlation coefficient. So R is equal to 0.42. So in this way I will write the final report, and that's it. Thank you for watching, and in the next video we will continue our hypothesis testing.